Alright, this is 4D notes. We're going to be solving quadratic equations by factoring. So to remember to solve by factoring, once you have factored the polynomial, use the zero product property to set factors equal to 0 and solve for x. Because if we know that two factors multiplied together equal 0, then one of them has to be equal to 0. So let's put this into application. Alright, look at our first problem. Alright, so we want to first of all look at when we have a trinomial like this in standard form. Standard form, remember, looks like this. The first thing you want to do, or the most efficient way to solve this, is solving by factoring. So let's see if this factors. So you want to multiply a times c, so you don't know what multiplies to give you 30, but adds to give you negative 17. So negative 15 and negative 2. All right, let's factor. We're going to rewrite that middle term. Group the first two, group the second two. Factor out of 5x. Factor out our negative 2. So my factors are 5x minus 2 and x minus 3. So now we're going to apply the zero product rule. So we're going to set each factor equal to 0. Now this is a quadratic, x squared, so we're looking for two answers. So 5x minus 2 equal to 0 and x minus 3 equal to 0. Solve for x. So 5x equals 2 and x is equal to 2/5. So that's one of my solutions, and then my other solution is x equals 3. Now, you should always be checking equations. You can always plug back your answers in to see if they're correct. We'll talk about some methods of using the calculator to check our answers in class. Alright, so we're just going to practice this. Same concept for the next three problems. We're just going to different problems to factor. Alright, this problem, it's not in standard form, so we need to rewrite that first, put it in standard form. Now you want to factor. So our lead coefficient is 1, so 1 times negative 36. So what multiplies to give you negative 36, but has a difference of negative 5. Alright, so negative 9 and positive 4. Alright, here again, factor. Pull out a GCF. So my two factors are x plus 4, x minus 9. Alright, apply the zero product property, so set each factor equal to 0. So my two solutions are negative 4 and positive 9. So we write those in a set, negative 4 and positive 9. Here again, take the time to check your answers. Go back and plug them back in. Alright, look at our next problem. Alright, it's already in standard form. Doesn't have a GCF. Always look for GCFs, greatest common factors, when you go to factor something. This one doesn't have one, so let's do A times C method. So 4 times 15 is 60, so it multiplies to give you 60, but adds to give you negative 17. Alright, hopefully set negative 12 and negative 5. Alright, let's factor. Like I said, if you're using my method, as long as you can factor correctly, I'm fine with whatever method you use, as long as you know how to factor correctly and consistently. But this method that I'm doing will work for any kind of any kind of trinomial factoring that we do. Alright, so there are my factors. So next we're going to apply the zero product property. Solve for x. So x is equal to 5/4. And here again, solve for x, and x is equal to 3. Okay, so our two answers are 3 and 5/4. Here again, check your answer. Plug them back into the original equation. Make sure they both work. All right, one more of these before we move on to a little bit slightly different topic. All right, if you look at this one, you say, oh, I got some work to do first. I got to get it in standard form. So that means everything needs to be moved to one side, combining like terms. So 3y squared. All right, I'm going to add 14y to 22y and get 36y. And I'm going to add 48 and 60 and get 108. All right, so now look. All right, let's see. 3, 36, and 108. They all have 3 in common. And since this is set equal to 0, all right, I can divide both sides by 3. I can't do this when I'm just factoring, but when I'm solving an equation, I can get rid of that common factor, that GCF. All right, so it makes me a new equation. What is it? Y squared plus 12y plus 36 equal to 0. And like I said, I can do this because I'm solving. I have equal to 0, so I can divide both sides by 3. But I cannot do this when I'm just factoring. If I'm just factoring, I got to keep that GCF. All right, now I'm going to factor. So what multiplies to give me 36, but adds to give me 12? All right, so we got 6 and 6. So we're going to factor. Rewrite that middle term. And maybe at this point you're recognizing a shortcut if my lead coefficient is 1. And that's fine if you recognize that shortcut. All right. So here my factors are the same. So I just set 1 equal to 0. So I have a single answer here of -6. So here's an example where we can have just one answer. So we've had 2 answers and 1 answer. All right, that's solving by factoring. You did this in Algebra 1, so just look, hopefully a quick review. All right, next what we're going to look at is solving equations with square roots. So here you notice that we don't have we just have an x squared term in this problem. So here what I can do instead of factoring is I'm going to isolate that x squared term. Now keep in mind that I still have 2 answers that I'm looking for because it's a quadratic, it's a squared equation. All right, so I want to isolate the x squared. So I have 1/2 x squared. I'm going to add 4, then multiply by 2 and get 8. All right, now I need to isolate x. So I'm going to take the square root of both sides is what I'm doing, taking the square root of both sides. But when I do that, all right, I'm going to get x is equal to plus or minus the square root of 8. Anytime you're taking a square root in an equation, you got to remember you need that plus or minus because that's where my 2 answers are coming from. Because you can square a negative and still get 8, and we can square a positive and still get that 8. All right, now remember from geometry, you want to break down this. We want to simplify this. We're looking for the largest perfect square in 8, which is 4. So what is happening here, this is plus or minus the square root of 4 times the square root of 2. Well, the square root of 4 is 2, square root of 2 is our final answer. But here again, you can't forget that plus or minus when you need that plus or minus. All right, let's look at another one. All right, here. All right, if you notice first, I've got 2 x squared terms, no x terms. So I can isolate those x squared terms. First of all, I need to distribute that 2. So I get 2x squared minus 10 is equal to negative x squared minus 1. I want to isolate the x squared terms. So I'm going to add x squared. So I'm going to get 3x squared minus 10 equals negative 1. I'm going to add 10, so 3x squared is equal to 9. Divide by 3, so I get 3. So now I'm going to square root both sides, so x is equal to plus or minus the square root of 3. And that's as simple as I can get it. So my 2 answers are negative square root of 3, positive square root of 3. And here again, I will talk about how to check this in class. But here again, you can plug these back in and also check. Okay? All right. Now look at a problem like this. Here again, this is a factor that I can isolate. You don't want to expand this because you're going to make this a much nastier problem if you expand that. So what I'm going to do is I'm going to treat that factor x minus 4 as kind of like my variable. I'm going to get that by itself, and I'm going to show you how to handle that. So that means I want to add 2 first. Can't distribute that 1/3 in there because that's squared. All right, so add 2 and I get 11. Multiply by 3, get 33. All right, like I said, now this is a single term. So now we can square root both sides. So when I take the square root of x minus 4 squared, I just get the x minus 4 back equals, now don't forget that plus or minus, the square root of 33. I just square rooted both sides. All right, now here again, I got to solve for x. So now I got to isolate x. So x is equal, add 4 plus or minus the square root of 33. This is an irrational answer. So other two problems have had irrational answers too. So your two solutions are 4 minus the square root of 3 and 4 plus the square root of 3. Those are my two answers. And those are just irrational numbers. All right, now if you'd like to try this one before we go over together, stop, pause the video, try the problem, and then come back and go through the video with me. All right, here again, I don't want to expand this. I'm going to isolate that term. All right, well, that's already by itself, so my only step I'm going to have to do with this particular problem is take the square root of both sides. So I'm going to have 4x minus 5 is equal to plus or minus the square root of 64, which is 8. All right, now these are all numbers. Okay, there's no irrational numbers up here. So I'm going to have to take this a step further. I'm going to break this into two separate equations where one is equal to negative 8 and then 4x minus 5 is equal to positive 8, and I'm going to solve for x each time. So 4x is equal to negative 3, x is equal to negative 3/4. Here 4x is equal to 13, x is equal to 13/4. So my two answers are negative 3/4 and 13/4. All right, let's do one more. All right, so here again, I see that's already been factored for me. That's already, so I'm going to isolate that term. So the first thing I'm going to have to do is add 8. Add 8, and I'm going to get 6. All right, then I'm going to have to multiply by 3/2. So 6 times 3/2. So I'm going to get 3x minus 2 squared is equal to 9. All right, my goal is to get this by itself, so I need to get rid of that square. So I'm going to square root both sides. We're square rooting. That means I need a plus or minus the square root of 9, which is 3. All right, here again, break this into two separate equations. So you're going to have 3x minus 2 is equal to negative 3, and 3x minus 2 is equal to positive 3. All right, solve. 3x is equal to add 2, that's negative 1. So x is equal to negative 1/3. All right, add 2, you're going to get 5. So x is equal to 5/3. So my two answers are negative 1/3 and positive 5/3. Okay. All right, so that's what we're going to be working on a 3D notes or 3D practice today. If you have any questions, please ask in class.